In this video, we're going to get some practice on how to use the steam tables. And we're going to look at this exercise here. Now, for each of these states, it gives us two properties, and we have to find the other properties. So this will give us some practice. Let me start with this number 3, the state number 3. We're given that it's 140 psi and 500 degrees Fahrenheit. And we have to find the properties. So that's number 3. And the pressure is 140 psia. And the temperature is 500 degrees Fahrenheit. Now, there's a lot of ways you can do this. I usually start by looking at the saturated mixture table. We could either look up the pressure or the temperature. Let's look up the pressure. Again, I'm looking at the saturated steam water table, it's called in my book. And I'm going to look up 140 psia. And so at 140 psia, so down the pressure, we see that the saturation temperature here is 353.08 degrees Fahrenheit. So if it's a saturated mixture, for example, or saturated vapor, saturated steam, the temperature at 140 psi is going to be 353 degrees Fahrenheit. Now, in our case, our temperature is higher. It's 500 degrees Fahrenheit. So right away, since it's higher, we know that we're going to have superheated steam. Because we're above the saturation temperature for 140 psia. So now we go over in the superheated table and look up 140 psia. And that's this over here. And we look up our temperature, which I just said was 500 degrees. So look, 140 psi, 500 degrees. And we can go right over here and find all the properties that we need. The specific volume is 3.952. The internal energy, again at 500 degrees and 140, the internal energy is 1172.7. Now, since it's superheated, there's not going to be any quality involved. And under the phase, we just say superheated steam. Like this. And if we were going to make a little diagram, a TS diagram, it's going to be over here in the superheated range, somewhere over here. So that would be a basic little graph you could make for that one. So now let's take a look at another one here. Let's look at maybe number 5. We're told we're at 450 psia and it's a saturated liquid. So the pressure is 450 psi in saturated liquid. Now, for saturated liquid, remember what that means? It means like on our TS diagram, we're going to be right on that left edge right there, just when we're changing from liquid to a mixture. So it's going to be that point right there. And we can find all the other information by looking up in our table. Again, look at the saturated mixture table and look up 450 psia. Going to be a little bit ways down the table here. So there it is, 450 psia. And the temperature is going to be 456.39. You can read that. And then the specific volume. Now for saturated liquid, we look up the subscript F. So when we're looking up the saturated volume, excuse me, the specific volume, we're going to look up 450 and VF, which is 019. I'm going to round it off like that. And then also for the specific internal energy, again, look up 450 psi. And again, we're going to look up UF in our table. Look under UF here. And if you slide down, that's going to be right here, 435.7. Like this. Now we're told it's a saturated liquid, and we can also say that in that case, the quality is 0. Remember, when we're on our TS diagram, if it's on the left edge, the quality is going to be 0, so X is going to be 0. So let's look at another one. Let's look at number 6 here. Here we're told number 6 is saturated vapor. This time we're given the temperature. So we're going to have to look up in the saturated mixture table, 370 degrees Fahrenheit. So you can see over here, saturated steam water mixture. And we're going to have to go down to 370 degrees Fahrenheit. And that's going to be on the next page here. And it's going to be this value here. And for 370 degrees, we see the saturation pressure is 173.23. And also, since it's a saturated vapor, we're going to be looking for subscript G this time. Remember, for saturated liquid, we look up subscript F. Now we're going to look up subscripts G. So under 370 degrees, look up V of G. That's going to be 2.628. Like this. And then again under 370 degrees Fahrenheit, look under UG, and that's to be 112.9. Like this. Your tables might have slightly different values. They often redo these tables, so I'm not sure if yours are going to be the same or just very slightly different, but it should be pretty close. Now, again, since we're saturated vapor, we're going to be all the way to the right, so X is going to be 1. And again, if you would make that on a TS diagram, this was for number 6, it would look something like this, and you'd be way over here like this. Next, let's take a look at number 7. This time, number 7 says we're at 700 psi, and we're given a quality. So since we're given a quality between 0 and 1, now we have a saturated mixture. So number 7, again, we're told pressure is 700 psi A. And we'd have a mixture like here, 0.65, somewhere here. So to look, you can sort of figure it's going to be, again, 65% along this line here. So it's going to be approximately there. And so now when we're going to have to calculate some things, first of all, again, we're going to look up 700 psi in the saturated mixture table. And 700 psi. And at that point, the temperature is 503.23. We'll round it off there. Now, this time, we're going to have a quality of 0.65, so we're going to have to do a little bit more work. Let me actually show it right down here for number 7. And so when we calculate our V, that's going to be our VF plus X times VG minus VF, like this. So we're going to look again up under 700 psi. Our VG was 0.6558. Our VF is 0.2051. And when I put that in my calculator, I got something like 4334. And so we can put that up in our graph here. 4334. Again, you might get slightly different. Your table could be just slightly different. And same with U. We want to calculate our U value. And it's going to have the same equation. And again, we'll have to look up UF and UG at 700 PSI. So again, if we look down here, now one thing to notice here, our UF is 488.9. And again, our quality is 0.65. Now, one thing to notice here that we, in our table for the internal energy, we have this UFG. That's the difference between UG and UF. That's going to be that difference. And so we can actually use that rather than having to calculate this difference here. So some tables have this, some don't. If your table does not have a UFG, then you have to use these two values and subtract. But again, my table has it, and that UFG, be sure I have the right column here, is 628.2. Like this. That gives us 897.23. And we can put that up into our little table here. Like this. So we've filled in all the values. And actually, since we have a quality here that's between 0 and 1, this is going to be a saturated mixture. Like this. So let me do one we haven't, one type we haven't done before. Let's go back maybe to number 4 here. Let's take a look at this one. Number 4 says we're at 350 psi A and 300 degrees Fahrenheit. So once again, let's go to our saturated mixture table. That's usually a good place to start. And look up 350 psi. And if I look on my table here, that's going to be this value here. Now notice this time the temperature is 431.82. That's the saturation temperature associated with this pressure. But this is higher than the temperature we have. We have 300 degrees. So what that means for number 4 here, it means that we're going to be, I'm not making these graphs all the same, but they're supposed to be the same. But it's going to be down here in the compressed liquid area. Because we have down here in compressed liquid. So that's going to be the phase description. So again, now that we have determined we're in the compressed liquid region, how do we find the properties there? Now, if you have a table for compressed liquid, you can use that. If not, what's very close is to use the properties based on the temperature that you have. Now, in this case, the temperature we have was 300 degrees Fahrenheit. And so we're going to have to look at our saturated steam table. Look under 300 degrees Fahrenheit, which is this value over here. And now, so we're going to use that. Of course, we know what the pressure is. But now to find the other properties, again, we're going to look under subscript F. So this is going to be because we're compressed liquid. So this is going to be 0.017. For our specific volume. Then for U, 300F. This was 269.52. Again, use the properties based on the temperature in the saturated mixture table and put these values in here. So again, we use the temperature of 300 and our U of F was 269.52. Now again, it's not going to have a quality because it's a compressed liquid. For the next one, we're going to look at the same number. We're going to actually change this to 350 psi. And our internal energy is 915. So once again, let's look at the saturated mixture table at 350 psi. And if you go across and look over here, let's see what U of F is. U of F is 408, and U of G is 1119. Now, our value is somewhere in between those two. So we know that we're going to have a saturated mixture here. And again, we know we're at 350, so we're saturated mixture. So our temperature is going to be the temperature associated with this 350. So in this case here, 350, and our temperature is 431.82. Like this. Now, to find this, we are going to have to find the quality. So let's take a look at that. So again, we know we're somewhere in the saturated mixture range because we determined that our internal energy was between U of G and U of F. So again, our value somewhere in here, we're going to have to calculate our quality. That's going to be whatever U value we have minus U of F divided by U of G minus U of F. Now our value is 915. And at 350 psi, our U of F is 408.7. Now, my table gives this difference. They call this difference UFG, so I'm just going to use that. Might as well take advantage of that at 350 PSI. That is 710.3. Again, if your table doesn't give that difference, you have to just do the subtraction here. When I put that in my calculator, I get 713 for the quality. That's going to put us again about 75% across, so be something like that. And so let me write this down here. 713 like this. Now also we want to find the specific volume. Now that we have found our quality, we can go back and calculate this VF plus X VG minus VF. And again, we're dealing with 350 PSI. So VF is 019,124. And our X is 713. And our VG is 1.3267 minus our VF. When I put that in my calculator, I got 95.14. Again, your value might be slightly different if your table is slightly different. So that's going to give us 95.14. And then we have all the values finished for that one. So now let's take a look at one more here. Let's take a look at number 10. In number 10, we're given the 250 PSI, and we're giving an internal energy of 1246.7. Let me just break that down. And P was and U 1246.7. So once again, let's start with our saturated mixture table. And I'm going to look up our pressure, 250 PSI. And then let's look up our internal energy. In our case, it's 1246.7. Now, if we look at across our line here, let me see if I can pull this back a little bit so it's easy to see the whole table. That's a little bit hard to see, but if you can maybe see 250 PSI is down here, but then if we go across, this is U of G, 1116.7 is the U of G at that pressure. And notice that that is less than our internal energy. Our internal energy is 1246.7. So that means that we're like out here somewhere. Like this. So that means we're in the superheated range. So let's go to the superheated table at 250 psi. So let's look here and let's look at 250 psi down here. And we're going to have to find this internal energy is 1246.7. So let's look up here under U. 1246.7. And that's this value right here. So that's telling us that occurs 250 psi, and our internal energy at 1246.7 occurs at 700 degrees Fahrenheit. So we can put 700 degrees in here. And then to find our specific volume, we can look at that same graph here where we found the 1246.7. Then this column here is for the specific volume, and that's 2.688. Like this. And now this was superheated steam. And that's what we have. Again, this is the picture looks something like this. We're out here. Now the ones I didn't do, this one, number 8, is very similar to number 5. The only difference here is you're given the temperature and told it's a saturated liquid. So you just look under the saturated mixture table, but look up the temperature. This here is very similar to number 7. You're given, this time again, a temperature instead of a pressure, but you're given a quality, so it's very similar to number 7. And number 2, when you look this up, this is going to be very similar to number 1. The only difference in number 1, you're given the internal energy. In this one, you're given a specific volume. Then you'll have to figure out what the quality is and go from there. So that's a simple introduction here to how to use these tables.